Hi guys, this is Shakil Ahmed, and in today's tutorial we learn more about the association between variables. In previous lecture we already learned that the two variables were on nominal scale and the association between the two variables were uh, measured or checked through chi-square test and from the option of cross tabulation. The chi-square method provide the association significance of association between the two variables on the basis of chi-square value and the p-value. In today's lecture we assume that one variable is on at least on interval scale or higher, and the one variable is on weaker scale, that is on nominal scale. In such situation we go to the option of analysis again, and then descriptives, and again on cross tabulation. We have already two variables, age and gender, in the boxes. Put the continuous variable in one box and the nominal variable in other box, and then go to the option of statistic. You can uncheck correlation and tick on eta. Basically eta is used when one variable is nominal and the other is at least on interval. So by continuing and clicking on OK, we will see the result: directional measures. This is just provide the value of eta just provide the strength of association between the two variables. Age of student taking as dependent variable and taking the gender variable as the dependent variable. So for such cases we often take the variable on the continuous scale as the dependent variable and the variable on nominal scale as the independent variable. So age of student as dependent variable gives 0.519 association between the two variables. There is a moderate relationship between the two variables. One was on quantitative or continuous scale, and the other was on categorical scale. So this is the measure of association or degree of measure of association. In this output you just skip this table. This is basically the cross tabulation between gender and age. For continuous variable this table might be much larger in case of larger n. So just skip this table and go to the option of directional measure and take this value for your purpose. Now we assume that both variable on continuous scale, then it is just simple option. Just go analyze and go to the option of correlate and then bivariate, then just click that student score and age of student. These both variables are on continuous scale. Just go to the option of mean and standard deviation. You also calculate mean and standard deviation, but for now we just continue and then click on tick on Pearson for the case when the both variables are on continuous scale, and then click on OK. We see the value 0.346, which is Pearson correlation between age and student score in subject A. The p-value provide that the correlation is insignificant, that there is no relationship between the two variables. So this table of correlation is used when both variables are on continuous scale or on at least interval scale. If either of one variable is measured on a weaker scale, ordinal, then interval, then we go to the option of analysis again and then correlate, bivariate, then we tick the Spearman rank correlation test rather than Pearson, and then click on OK. We see the value which is slightly higher than the previous value, which is 0.367. But here we again use the variables age of student and student score in subject A. No ordinal variable were used, so we again go to the option of analysis and then replace the variable student score on ordinal scale. This is which is grade of student, but wrongly it is labeled as nominal variable, so I will change the scale of measurement for student grade to ordinal, and then will again check the grade of student to the variable box and then click on Spearman and then OK. You will see the table 0.509, which is the association between student age and grade of student, and this is also insignificant, showing that there is no significant relationship between age of student and student's grade. So guys, the point should be noted that the Pearson correlation coefficient assume that both the variables are on continuous scale or at least on interval scale, but this Spearman correlation coefficient assume that the one variable should be at least on ordinal scale rather than the strong assumption of interval scale. So the Spearman rank correlation test is preferred for the variables measured on ordinal scale. So these are about the measure of associations between the variables. We see the measure of association between two qualitative variables in previous lecture as just on the basis of cross tabulation, and in today's tutorial we learned the association between a continuous variable and a categorical variable through cross tabulation, and the eta measure is used instead of correlation. And for two variable, one is ordinal and one is interval or ratio, then we opt for the Spearman rank correlation, and when both variables are at least one of them is on interval scale, then we just proceed with Pearson bivariate correlation, which is the strongest measure of correlation between the two variables. But the assumption of scale of measurement of data is much tougher, so we opt for other measures when the data is not on interval scale. So thank you for watching the video, and I hope you guys understand the different measures used for correlation or checking the association between the variables. So don't forget to subscribe our channel and keep watching. Thank you.